This is video lecture for week 8, the second part B. Here we discuss the increasing and decreasing functions and the first derivative test. A function f is increasing for two values taken from the interval I with x1 less than x2. F of x1 should be less than f of x2. That means fx gets larger as x gets larger. A function f is decreasing on the opposite. For x1 less than x2, f of x1 is greater than x2. Just the opposite for the same values here, x1 less than x2. If f of x1 is less than f of x2, that is fx gets larger as x gets larger. And here in the opposite, if fx gets smaller as x gets larger. That means x1 less than x2, x1 less than x2 is the same. Only the value of the function is either lesser or value of the function is greater. Well, the same definition we will put it in the form of a derivative. If the derivative f prime x is greater than 0, then f is increasing. If f prime x is negative, then f is decreasing. That means what? For the curve, you see a tangent at this point, tangent at this point, right? A tangent at this point. You see that here the function is increasing, here the function is increasing, here the function is increasing. Then tangent line have positive slope. So whenever the graph is increasing, and if you draw a tangent line, remember it has a positive slope. So tangent line have positive slope whenever the function is increasing. At this point 1, here at this point, and at this point you see that the f is decreasing, and if you see the tangent line, that is the slope, the tangent line have negative slope. So there is a connection here. When the slope is positive, f is increasing. When the slope is negative, f is decreasing. Let's see an example here. Draw the graph of this showing all extrema. So we have already done this question. We find the derivative and we find the critical number, and they are 1 and minus 4. Then what we do here is this and 1 and minus 4, you leave this two graph, only you check this, only this part. Okay, so you just show where it is. So 1 is here, right? Minus 4 is here, that is to the left of 1. Then at minus 4 and at 1, the f prime x is 0. So this 0 is the derivative 0. So that is the critical point, critical number, this and this. So this is the value of f prime x. This is your f prime x, right? Now you give any value less than minus 4, that is minus 5. So when I put here in fx, x is equal to minus 5, f prime is positive, because minus 5 minus 1 is minus 6, minus 5 plus 4 is minus 1, so minus into minus plus, so it is plus here. Then you give any value after minus 4, that is greater than minus 4, it is minus 3. If you substitute x is equal to minus 3, it is negative. You see, I have negative here. Then you give any value greater than x, x is equal to 2, so this will be positive. Therefore, before minus 4 positive, after minus 4 negative, after 1 it is positive. Positive, see, increasing, negative, decreasing, positive, increasing. So what happens here? F prime x is positive on minus 4 to minus infinity to minus 4. You see, from here minus infinity till minus 4 it is increasing, and it is also increasing from 1 to plus infinity. You see, 1 to infinity. So f prime x is increasing at this interval, and at this interval is increasing. But f prime x is negative. you see, from here to here only. So it is -1, -4, 1. So open interval, not at the close, because at -4, at 1, it is 0. So looking at this, what you call, information, I can draw the graph. You see, I just roughly draw the graph, not exactly. So f prime, that is fx, is increasing from here to here. You see, from here I come. So I just roughly draw from here. You see, this is -4. So -4, it is increasing. Then after -4, it is decreasing. Till when? Till 1. You see, it is decreasing till 1 here. Then after 1, what happens? It is again increasing. You see, it is increasing. So using this information, I can draw the graph of the function. So very important one is the first derivative test. The first derivative test, what it says, that if you know the interval of increasing and decreasing, then we will be able to find what you call the local maximum and local minimum. That is, if f prime x is greater than 0 for all between this interval, and it is negative in this interval. So note that in this interval and this interval are open, and there is a common c. It ends with c and it starts with c. It's very important. This AB can be anything, but this, the first function should be, the first interval, open interval, should be end with c. The same thing should start with c. And if this is so, then FC is local maximum. If you have, it is greater than 0, local maximum. If it is less than 0 between AC and CB, you see, again C is common, it is open interval, then it is called FC is the local minimum. But in these two, look at it, here the signs are changing. Positive become negative from this interval to this interval, negative becomes positive from this interval to this interval. But from this, but if it is not changing the sign, the sign of this f prime x is remains the same. Please remember, there is FC is not local extremum. So the sign must change. Then it is, so positive to negative, local maximum. Negative to positive, local minimum. If it is positive, positive, negative, negative, that is the same sign, then FC is not a local extremum. You see here, this is the local maximum. Here, f prime c is increasing, greater than 0. After this, it is decreasing, f prime x is, so positive, negative, you see, positive, negative. But C is common here, this is C is common from A to C, then C to B. So local maximum. Here you see, from here to here, decreasing, and from here to here, increasing. C is common, therefore it is local minimum. Let's see an example of that. Find the local extrema using the first derivative test. It's very clearly given which test to be used. Find the local of this. So this, okay, and we have done this example in the earlier one, 4.1, and what we have seen, f prime x is greater than 0 from this to this, and it is greater than, less than 0 from this to this. What we do, we combine these two. So f prime x is greater than 0 from here to here, f prime x is less than 0 from this to this, this -4 is c here, which is common. Therefore, it is increasing, decreasing. Therefore, f has local maximum at x is equal to -4 according to the first derivative test. Now what I will do, it is increasing here and decreasing here. You see, here we have a, first I will take f prime x is greater than 0, less than 0 with this, and f prime x is greater than 0 at this. So first this and then this I combine. So see, 1 and 1 are c. So therefore, the fx has local minimum located at x is equal to 1. So be careful in combination. In the first combination, I take this and this. In the second combination, I will take first this and then this, because the first value of the second value of the first interval and the first value of the second interval should be the same. Similarly, in this case, you see we have fx, then I find the f prime, we have this, then I can apply both the rules to find the critical number. So I equate to 0, the x will give you 6 by 5, then I take the f prime x not defined, then x becomes 0, therefore we have what you call two critical numbers here, right. So we have f prime x is greater than 0, again we draw the line, yes, you draw the line, show 0 and 2 by 5, and you take the left and the right values and all that, you will see that f prime x is greater than 0 on these interval and also 6 by 5 infinity. So f is increasing. Then it is negative on 0 and 6 by 5. So what I will do now, I will combine carefully. So what I will do first, I will combine this and this, because this 0 and 0 is common. It is greater than 0 at here, less than 0 here. So therefore f has local maximum at x is equal to 0. Then I will combine this first and then this first, because 6 by 5 common. Therefore it is a local minimum at x is equal to 6 by 5. So please remember how you do this, how you know this. You have to go here, you have to draw the graph like this. You have to draw the graph. Don't look into these two, just draw this graph carefully and showing first the critical value and take one value on the left and on the right, then you will know this, then you can write this. Similarly, for this question also, you have to show this 6 by 5 and 0 on the graph and then check, you will see this. Okay, so that's the examples of this first derivative test and increasing decreasing. So these are the examples of this. So here in all these examples of earlier and here, you need not sketch the graph, only whenever it is asked, and here you are using the first derivative test, and here only you will be finding the interval of increasing and decreasing. So these are the answers for that, and what we have studied in this video lecture. Here we discuss, or we have studied, the increasing and decreasing function and the most important first derivative test. For what purpose? For finding the local maxima and minima. You see that in the earlier video lecture we have studied the how to find the absolute maxima and absolute minima. Here we are we have studied finding the local maxima and minima using the first derivative test. So you have to be very careful in distinguishing absolute maxima, absolute minima, local minima, local maxima, maxima minima, right? So all that thing you have to be very careful, plural, singular, what is asked clearly. Okay, so that's the end of the week number 8 lecture. So more detail we will continue later. Thank you.